Good day. Today, I will be discussing with you another topic. In our previous discussion, we understand the concepts of machine and machinery. That topic is very important for us to be able to understand how motion of mechanism happen. So once we establish what kind of motion we like and what kind of motion is expected using the different conditions that is presented in that topic, we are now ready to start the analysis of that motion. But before we proceed to the velocity and acceleration analysis, it's important for us to be acquainted with one technique which will be helpful in the velocity and acceleration analysis. And that is the instant center. By the end of this topic, you should be able to describe the concepts related to instantaneous center, illustrate mastery in locating the instantaneous center of linkages, and display interest in the practical application of instant center. This will be the outline of my presentation. So let us start first with the definition of instant center. So what is an instant center? Instant center was introduced by Johann Bernoulli. They are also called centros or poles. Basically, they are point that is common to two bodies in plane motion, and a point where the absolute instantaneous velocity in each body is the same. That means that the instantaneous velocity for, say for example, the link 1 would be the same as that of the link 2 in the common point, which is called the centro. Can be actual common point between two bodies, such as a pin joint, which we discussed in the previous topic, and can also be a virtual common point, which does not necessarily exist. Say for example, you can see here at A, we can find that the connection between link I and J, shown in red here and green, the joint connecting them is a pin joint, which is a common point between the two links. So that link is a centro. On the other hand, here at the bottom, we have the red link and the green link, and the common centro is not necessarily in them or connected or virtually present. So that is a virtual common point, but still considered a centro. So now that we understand what centro is, let us try to identify the different types of instant center. The first type is what we call the fixed instant center. So they are called fixed because they remain in the same place for all configuration of the mechanism. So that means that for whatever movement or whatever angle the mechanism would be, say for example the links, or whatever position the link would be, this remains at that position. So they are fixed. So they are not changing in location. The permanent instant center, on the other hand, they move when the mechanism moves, but the joints are permanent. So this means that unlike the fixed instant center, the permanent instant center can now move, but they remain in the same joint. And finally, we have the moving instant center, which vary with the configuration of the mechanism. So to illustrate the difference between the different types, so the first two types here, the fixed and the permanent instant center, are known as the primary instant center, while the third type, which is the moving instant center, is also the secondary instant center. Say for example, we have here a 4-bar linkage. So we have the link 1, which is the ground, connecting the A and B, the joint A and B, and then we have link 4 connecting A and B. Then we have the link 3, which is a coupler connecting the B and C, and then we have link 2 connecting C and D. So here we are going to locate first the fixed instant center. So by definition, the fixed instance center are fixed and not moving. So basically, they are at the ground. So the fixed instance center here is the joint 1, 4 and 1, 2. So you can see here, this link here is the 1, 2 because it's the connection between link 1 and link 2. So it's called 1, 2. So the name of the center is named after the link that is connecting them. And then this one here connecting link 4 and link 1, this joint here is another instance center which is fixed. So this is the I14. So these are the fixed instance centers. And then we have the permanent instance centers. So the permanent instance centers, they are moving, but they are not necessarily changing in terms of the connection. So as you can see here, the permanent instance center in this 4-bar linkage is the instance center 3, 4, which is connecting link 4 and 3, and the instance center 2, 3 connecting link 2 and 3. So they are moving because as the link oscillate or rotate, so they also move. So that's why they move, but the connection remains stays the same. So that's why it's permanent instance centers. And then finally, we have the moving instance center. So the moving instance center, these are the instance center that moves, as well as changes their position depending on the configuration. So here, the moving instance center are the instance center I13 connecting this link here, and then we have the 2, 4. So those are the different types of instant center. So by now, you may be wondering, how can we find or identify the instant center? Say for example, the moving instant center. So we will use the formula to determine first how many instant center exists in a particular linkage. So the formula is for a mechanism containing n number of links, the number of instant center is determined by the formula n multiplied by n minus 1 divided by 2. Say for example, if you have a 4-bar linkage, you have 4 links, so there will be 6 instant center if you substitute 4 in the number of links in the formula. So this formula will help us now locate the 6 instant center of the particular 4-bar linkage. So this is applicable even to 6, and even to 3 or other number of linkages. Another important concept that will help us in locating the instant center is the Kennedy's rule. So according to the rule, any 3 bodies in plane motion will have exactly 3 instant centers, and they will lie on the same straight line. So this means that what it's saying is, say for example, you have 3 links. So for 3 links, if you're going to substitute 3 in the formula, you will still obtain 3 instant center. So these 3 instant center, if they are in the plane motion, they will have 3 instant center and they will lie on the same straight line. And the second part of this rule is important because it will help us to know where they are located. So this rule does not require that the 3 bodies may be connected in a way. It's just that they should lie on the same straight line. So that's what we meant by the Kennedy's rule. So later on, we will illustrate the Kennedy's rule in some examples. So before that, let us try to understand the different steps in locating the instant center. So the first step in locating instant center, so there are different techniques, but for our lesson, I will illustrate to you this technique. So first, you are going to draw an IC circle or the instant center circle with the same corresponding number of links. So you have to count first the number of links, and then you draw an IC circle with vertex that are equivalent to the number of links. Locate as many obvious instant center. If you can observe, there are instant center that can actually be readily seen, just like the fixed and the permanent instant center. They can readily be seen. However, for the moving, we need to use the Kennedy's rule later on. So that's why we have to locate first those obvious IC, then label this IC accordingly. Then in the instant circle, we are going to connect these corresponding links on the IC circle. Third, identify a link combination on the IC circle for which the IC has not been found. Draw a dotted line connecting those two link numbers. So in the IC circle, all the numbers must be connected. So that's why we have to identify a combination on the IC circle which has not yet been found, so that we can find it by drawing a dotted line and then using the Kennedy's rule to obtain that particular IC. And then identify two triangles on the IC circle which each contain the dotted line and whose sides are solid lines representing the ICs already found. So because these vertex of these triangles are actually found also in the actual linkage. So it's important to identify two triangles on the IC circle which contain the dotted line and whose other sides are solid lines representing the ICs. Then you're going to extend the line connecting the two ICs on one triangle. Then you do the same for the other triangle. And then the intersection of the two extended line will locate another IC. And you're going to repeat these steps 3 to 4 until you can locate all of the instantaneous center. So let us try to look at these examples. So we have here a 4-bar linkage, and we are going to locate the different instantaneous center. So the step 1 there is to count the number of instant center using the formula. So in the formula, you're going to substitute n is equals to 4 because there are 4 links: link 1, link 2, link 3, and link 4. So the number of center is 6. Then you draw the instantaneous center circle or the IC circle. So you're going to place numbers corresponding to the number of links. So you can see here we have 1, 2, 3, 4. So we have 4 links. So we are going to draw 4 also here equally spaced around the IC circle. So they should be in order. So you have to make sure that they are equally spaced also, so that it will be easier for us to locate the other IC circle. Then the steps there is to locate first those instantaneous center that are of use. So these are the permanent IC and the fixed IC. So we have here the fixed IC found here at the intersection of link 1 and 2. So this is a fixed IC. So as you can see, we're going to note that, and then in the IC circle, we're going to connect 1 and 2 because this represents this IC. So the connection is the representation of the IC. And then another fixed is the I4. This is the intersection of 1 and 4. So we're going to draw the line, solid line for 1 and 4. So that's the solid line for 1 and 4. And then we have a moving instant center here at the intersection of 2 and 3. And then in our IC circle, we're going to connect 2 and 3 as well. And then we have another moving here, 3 and 4 at the intersection of 3 and 4, and connect also the 3 and 4 in the IC circle. So as you can see, we were able to get already 4 out of 6 instant center just by inspection alone. So the remaining instantaneous center are virtual instant center, so we have to locate them by using the IC circle that we already established. So according to the rule that they are actually connected by Kennedy's rule also. So how do we make sense of that rule? So the next step there is to connect 2 points so that you can create a triangle. As you can see here, if you connect 2 and 4, you can create 2 triangles. So by connecting 2 and 4 in the IC circle, you can create 2 triangles, the triangle 1, 2, 4, and the triangle 2, 3, 4. So this means that this instant center 2, 4 lies at the intersection of these sides 1, 2, 1, 4, or 2, 3, and 2, 4. So that means that if we extend, say for example, 1, 2, 1, 4. So this is the extension of 1, 2, 1, 4. So if we connect 1, 2, and 4, because this is the side of this particular IC24. So if we extend that, if we connect them, because 1, 2, and 1, 4 is the side of 2, 4. The third side is 2, 4. So we have 1, 2, and 1, 4. We're going to connect them. So connect 1, 2, 1, 4. So we have here 1, 2, 1, 4, and then we have 1, 2, 1, 1, 1, 2, 1, 1, 2, and then 1, 4. Then we connect them. So you just draw a line connecting them because they are on the side of 2, 4. Another side of 2, 4 is the 2, 3, 3, 4. So the 2, 3 is this one, and then the 3, 4 is this one. So we connect them. So we just extend. So you can see we connect them and extend. Now the intersection of these 2 lines is the instantaneous center. That is the third side, which is the 2, 4 that we wanted to find a while ago. So this is the 2, 4. So the intersection now of 1, 2, 1, 4, line 1, 2, 1, 4, and line 2, 3, 3, 4 is the 2, 4, the instantaneous center 2, 4. So that is how we use the IT circle, by drawing triangles and then using the sides adjacent to that side. So finally, we have 5 instantaneous center. Then we need to locate the last one. So we can draw another triangle by connecting 1, 3. So if we connect 1, 3, you can see that the sides of 1, 3 to form triangles are 1, 4, 3, 4, 1, 4, 3, 4, as well as 1, 2, 2, 3. So for 1, 4, 3, 4, so let's start first with 1, 2, 2, 3. So for 1, 2, 2, 3, so this side 1, 2, and then this side 2, 3. So this is the side of 1, 3, so that it can form a triangle. 1, 2, 2, 3. So we are going to connect 1, 2. So 1, 2 is here, and then 2, 3 is here. So we connect, then extend. And then the other side is the 1, 4, 3, 4. So this is the 3, 4, and this is the 1, 4. So we connect, extend. At the intersection then is the side that we are looking for, which is the 1, 3. So that is the instantaneous center 1, 3. So as you can see, using the IC circle, it's much easier to find the virtual instant center. So using Kennedy's rule, we verify our answers. Say for example, 1, 2, 2, 3, and 3, 4 composed of points 2, 3, 4, right? So we have 2, we have 3, and then we have 4. So the points so these 2, 3, and 4 lie on the same straight line. So as you can see here. So the 3 instantaneous center lie on the same straight line. So the line 2, 3, 4. Also here in our drawing, the 2, 3, and 4 is also connected to form a triangle. 2, 3, and 4. So another verification is 1, 3, 1, 2, 3, and 1, 2. So here, the points are 1, 2, and 3. So 1, 2, and 3 lie on the same straight line. So here we have a triangle 1, 2, and 3. So 1, 2, and 3, so they lie on the same straight line. And then we have another 1, 2, 2, 4, 1, 2, and 1, 4. So the points here are 1, 2, and 4. So they lie on the same straight line. So we have also here 1, 2, 4 triangle. So that's how we use the Kennedy's rule. So we verify if the line are connected by in the same straight line, the 3 points, And then they are also forming triangle in the IC circle. So if you notice some points that lie in the same straight line and then they don't form a triangle in the IC circle, then you have to check whether your instant center are correct. So here the permanent instant center are the 1, 2, 1, 4. The moving are 2, 3, 3, 4. And the moving, the fixed is 1, 2, 1, 4. The permanent is 2, 3, 3, 4. And then the moving is the 1, 3, 2, 4. So how about for a slider crank mechanism? So this is the slider crank mechanism because here, as you can see, when this crank moves, when this crank oscillates or rotate, the slider moves also horizontally. So it will not fly up or down, it will just, so the degree of freedom of this slider is just 1 because it is constrained to move horizontally only. It will not rotate, it will not move up and down, it will just move horizontally. So the degree of freedom is 1. So we have here, this is the slider crank mechanism. So first, we're going to compute the number of instant center by counting first the number of links. So the ground is 1, and then we have this link here 2, another link here 3, and then the connection between the slider here and the slider is considered also another link. So that's why we have 4. So the number of instant center that we are to locate is 6. Then we draw the IC center circle by spreading all the points, the number of links that we have. So we have 1, 2, 3, and 4. So locate the known IC circle, ICs. So we have the 1, 2, it's known. Then draw that in the IC circle. Another known is 2, 3. Then we have 3, 4. And then we have the ground. So for the ground, as you can see, the connection between 1 and 4 is actually that it's infinite because there's this slider here is actually connected all the time to the ground. So that's why, if that is the case, the IC is actually a line which has an infinite number. So this is how you draw it if it is a slider on the ground. So for the slider on the ground, the IC 1, 4 is actually a line, an infinite line. So you can see here, I14 at infinity. So this is perpendicular to the ground. So that is your 1, 4. So take note because 4 is a slider and then 1 is a ground. So if you have a slider on the ground, the IC is actually an infinite number. So now that we locate the 4 out of 6, then we need to find the others. So first, the IC24. So just like before, the adjacent to 24 is 1, 2, 1, 4. So for 1, 2, 1, 4, so the 1, 2, 1, 4, because as you can see, because 4 is infinite, so the connection between 1, 2, because 1, 4 is infinite rather, the side 1, 4 is infinite, the 1, 2 will also become, the connection between them will also become infinite. So that's why it's also, the line looks like this way. So we just have a parallel to the instantaneous center 1, 4 at the IC 1. So that is how you draw now the 1, 2, 1, 4. So this line now represents the 1, 2, 1, 4 already. So 1, 2, 1, 4 because it should be parallel to the infinite 1, 4. And then the other side is 2, 3, 3, 4. So the 2, 3 is here and then we have the 3, 4 here. So we just connect them. And the intersection is the 2, 4. So this is the 5th instantaneous center, which is a virtual instantaneous center. And then we connect 1 and 3. As you can see, the side of 1, 3 is 1, 2, 2, 3. So the 1, 2 is here and the 2, 3 is here. So we connect. And then for the bottom one, we have 1, 4, 3, 4. So the 1, 4 is infinite. 3, 4 is also, the 3, 4 is the point. So basically the 1, 4, 3, 4 is this line also already because it's the infinite one. So that the point connecting them is the instantaneous center 1, 3. So this is the case when we have an infinite IC. So that's why we have the instantaneous center here 1, 3. So finally, we were able to locate all of the instantaneous center of this slider crank. So we verify if this is true. So if you look at this line, say for example, it contains 1, 2, 3. So the 1, 2, 3 forms a triangle also here. Then the 1, 1, 4, 3 so also forms another triangle. Then we have 2, 3, 4 also connects a triangle. So as you can see, we verify using Kennedy's rule that the 3 instantaneous center lies on the same straight line. And then finally, we have a 6 bar as an example. So for a 6 bar, because it consists of 6 links, then we will get 15 instantaneous center. So we are going to locate all of the 15. So for this problem, we're already draw the permanent as well as the fixed in the IC circle. So we just spread out the 6. So 1, 2, 3, 4, 5, 6. And then we already draw here already the known, which is the 1, 2. It's already connected, as you can see. Then we have the 2, 3. It's also connected already. Then we have the for this point here, because it's connecting, it's a 3 linkage joint. So if you can remember, it has a degrees of freedom of 2 because it's -1 always. So it's actually composed of 3 centers, which are the 3, 4, 4, 5, and 3, 5. So that's why we can connect already 3, 4, 4, 5, and then the 3, 5. So that's why we have the solid line here. So take note that for the fixed and the permanent, we draw it using a solid line. So this is 3, 4 because it connects 3 and 4. This is 4, 5 because it connects 4 and 5. This is also 3, 5 because it connects 3 and 5. So basically 3 IC at one point. And then we also have 6 here connecting 5 and 6. So that's why we connect 5 and 6 also here. So connected already. And then also you can see that 6, 1. 1 is the ground. So for all the ground, we name them 1. So as you can see here, the ground is 1. Same also here, the ground is 1. Then we have here ground is 1 because the ground will there will always be one ground, right? The planet Earth, or the ground, the floor, the surface, so by which the machine is placed. So the connection is 1 and 6. So that's why we have connected here 1 and 6 already. And then for this one, the last one, we have so the 1 and 6 is actually 1, 6 at infinity because again, 1 is a ground and 6 is a slider. That's why it will have infinite IC here at this point. And then the last one is the 1, 4. That's why you can see that 1, 4 is already connected. So as you can see, we draw the solid for all the known. Then based on that, we already have 1, 2, 3, 4, 5. We have 6, 7, 8. So we are to locate the remaining 7 instantaneous center using the IC circle. So first, we need to analyze the IC circle so that when we connect 2 points, we can form a triangle. So that's always the rule, in the IC circle. So when we connect 1 and 2, connecting 1 and 3 rather, 1 and 3. You can see that when we connect 1 and 3, you can create a triangle here, 1, 2, 3, 1, 2, 3, and then another triangle here, 1, 4, and 3. So that's the first, that should be the rule when you connect first. If they will not form a triangle, then it will not, if it won't form 2 triangles, then you cannot locate that IC. So here, it forms triangle 1, 2, 3, and 1, 4, 3. So now it means that the intersection of 1, 2, 2, 3, and 1, 4, 4, 3 is the next IC. So we're going to draw the intersection of 1, 2, and 2, 3. So 1, 2 is here, this one, and the 2, 3 is this one. So we connect it. So the 1, 2, 2, 3, And then we connect also the 1, 4, 3, 4. So the 1, 4, 3, 4 is this one. The 1, 4 here and the 3, 4 is here. So we connect the 1, 4, 3, 4. The intersection now is the IC 1, 3. So that's the triangle. So we have here 1, 3. And then for the next IC, we need to find another 2 points that we can connect so that we can form a triangle. And this is actually 1, 5. So if we connect 1, 5, you can create triangle 1, 6, 5, and then the triangle 1, 5, 4. So as you can see, we have 1, 5, 1, 5, and 4. That is another triangle. So the intersection of 1, 6, 1, 5 and 1, 4, 4, 5 is the next IC. So for 1, 6, 1, 1, 6, 5, 6. So first we locate first the 5, 6. So 5, 6 is here. And since 1, 6 is infinite, so meaning it will have a horizontal perpendicular to this ground. So that the IC is this one. So it's vertical. It's a horizontal, but it's perpendicular to the ground. So this is the intersection of 5, 6, and 1, 6. And then for the side 1, 4, 4, 5, so we have here the 1, 4. This is the 1, 4 and the 4, 5. We already had that. So this is actually the 1, 4, 4, 5. This line here is actually the 1, 4, 4, 5 because it connects 1, 4 and 4, 5. So the intersection between the two is the IC 1, 5. And then we will locate again another triangle. So when we connect 2 and 5, you can see here that the adjacent sides are 1, 5, 1, 2. So we have the triangle 1, 2, 5 and the triangle 2, 3, 5. So first we locate 1, 2, 1, 5. So 1, 2 is here and then the 1, 5 is this one. So 1, 2, then 1, 5. So we connect 1, 2, 1, 1, 5. And then the other side is 2, 3, 3, 5. So 2, 3 is this one. 3, 5 is this one. So we connect. So the intersection is that point. So that is the IC 2, 5. And then another triangle that we can locate in the IC circle is 3, 6. So if you connect 3, 6, you can get the sides are 1, 6, 3 and 3, 5, 6. So we have 1, 6, 3, 1, 6, and 1, 3. So our 1, 3 is located here. So this is the 1, 3. And then the 1, 3, the 1, 6 is infinity. So therefore, it should be parallel to this infinite. So that's why we have a parallel to this infinite 1, 6. So therefore, and then the other one, we have the other triangle is we have 3, 5, 5, 6. So the 3, 5 is located here at this point, and then the 5, 6 is located here. This one. So we connect them, 3, 5, and 5, 6. Then the intersection is the 3, 6. And then another IC is the 2, 6. So for the sides of 2, 6, so if you can see, we have the sides 1, 1, 2, 6, and another triangle 2, 3, 6. So we have 1, 2, 6. So we locate first 1, 2. So this is 1, 2. And since 1, 6 is infinite, it should be horizontal. It should be perpendicular to the 1, 6 infinity. And then we intersect that with the other side, which is 6, 2, 3. So we have 2, 3, and 3, 6. So the 2, 3 is somewhere 2, 3. So this is 2, 3. And then we have here the 3, 6. So we connect that, 2, 3, and 3, 6. And then the intersection between those two lines is here. So this is the next IC, which is the IC 2, 6. And then finally, we have another one, which is the 4, 6. So for 4, 6, it can form triangle between 5, 6, and 4, 5. So the 5, 6, 4, 5. So the, okay, first we will use the, no. Okay, we will use the 3, 6, 3, 4. Okay, the sides are 3, 6, and 3, 4. So it's another triangle. So 3, 6, 3, 4. So 3, 6 is here, and then 3, 4 is here. So meaning it's just this line, no? The same line. And then for the other side, we have 5, 6, 4, 5. So for the 5, 6, 4, 5, okay, the other side is, okay, I got lost. Okay, let's, okay, so the side is, yeah, 5, 6, 4, 5. So for the sides 5, 6, 4, 5, so this one is the infinite muna now because this is the line connecting. This is the perpendicular to the 1, 6. So the 1, 6 here, the infinity. So 1, 6 and 1, 4. The 1, 4 is this one, and then the infinite, because it's 1, 6 is infinite, that's why we have a horizontal. And then the intersection between them is this point. So this is now the IC 4, 6. And then the last one, the 2, 4. So the 2, 4 connecting 2, 4 are 1, 4, 2. 1, 4, 2, and 2, 3, 4. So 1, 4, 1, 2 is, so we have here 1, 2. And the 1, 4 is this one, so we connect them. And then for the other side, we have 2, 3, 3, 4. So this is the okay. So the one, if you locate, you can actually locate now these points again by we have 2, 3, and 4. So 2, 3, 2, 3, 3, 4. So the 2, 3 is here, and 3, 4 is here. So if you extend this line, so actually the IC is also cannot be, they do not intersect. So that is how you locate the IC, the different IC. So now that we understand the definition, the types, how to locate how to compute the number of IC, how to use the Kennedy's rule, as well as the steps in locating the instant center using the different example, let us try to examine some applications. So an application, say for example, this lesson will actually be helpful later on in the velocity analysis of planar mechanism. And then it will also help us in determining motion transmission between links. So motion transmission meaning what will be the effect of one link to the motion of another link. So that's the motion transmission. As well as helpful and efficient in finding the input-output velocity relationships of complex linkages, such that of the 6-bar is a complex linkage. So it helps us in determining the input-output velocity relationship between this kind of linkages. And it also helps in singularity analysis of planar mechanism. So this is a more complex way of analyzing the planar mechanism. So for 4 bars, some example of your 4 bar, as you can see here, I believe that we encountered them, gear systems, as well as the sprockets system, wheel system. So these are actually considered as 4 bar because it's composed of 4 links. As you can see here, we have the link connecting the one part to another, and then we have another link 2, and then another link 3, and then the ground is another link. Another one here, we have the gearing systems here, which can be considered as the crank, the coupler, and the rocker. So this is actually another 4-bar linkage. For the slider crank, these are actually found in your engine and your IC or internal combustion engine. So the rotation, say for example, of this crank here allows the sliding of the piston head here, piston cylinder arrangement. So that's actually a slider crank mechanism. So the sliding produces the crank rotation produces the sliding effect, and vice versa. So because the force actually comes from the fuel mano because of the combustion, so that's why the input is here in the piston cylinder arrangement that causes the rotation of the crank. So that's the slider crank mechanism. And then for the spherical, this is the 6-bar linkage application, which is a spherical watt, which is also used in this application. So you can see, in order to create that kind of mechanism for that high-end car, they actually use the 6-bar linkage, which is the spherical watt. So it's a 6-bar. So the degrees of freedom actually allows motion of that particular part of the vehicle. So I hope that in this lesson, we were able to understand the instantaneous center, as well as how to locate it. It's very important later on, and how to apply them in the future and appreciate their application in our field of mechanical engineering. So if you want to know more about instantaneous center, you can click this link that we have, the instant center. This is actually, if you click that link, you will give you the YouTube video there, and then another link. So in this link, you just have to note, if you want to know more about IC center, if this video is not enough, then you can take note of the inspection method of finding central, using triangle to find the central, as well as in this video, you just focus on the finding central, because in that video, actually, the velocity analysis is already included. That's why you can focus only on the central, so that it will not be that complicated. So this is just a supplementary video if you want to learn more about the IC center. So see you.